Here's your first question. Sometimes I get asked to answer where in the actual program of everyday mathematics is the practice. And so can you actually talk a little bit about where the practice is? And if we are new to everyday mathematics, how and why does it look different than maybe what we're used to seeing in more of like a worksheet type practice?
I think a lot of times when we're asked, where is the practice? It means, where is the worksheet with 20 problems that all follow up on the exact same concept or skill that I just covered in the lesson that kids will do over and over to learn whatever skill they just covered in the main part of the lesson. And if that's what you mean by practice, well, there's not that much of that in everyday mathematics. And there are several reasons for that. We rely on a lot of research that shows that actually massed practice, which is a worksheet with all the same kinds of problems that you do over and over again, is really good for short-term learning of skills, but not for long-term learning, not for long-term retention of concepts and knowledge. And so our practice is more of a distributed practice where practice occurs over time. But that's not to say there isn't a lot of practice in everyday mathematics. There is a lot of practice in everyday mathematics. It's just spread out over time. We point teachers to look at the part 3 practice in lessons, which brings back concepts and skills from previous lessons, sometimes through journal pages and sometimes through games, to look at the math boxes, which are journal pages that bring back concepts and skills from previous lessons, to look at the mental math and fluency, which are also skills from previous lessons, to look at the differentiation options, which give opportunities for kids to practice concepts too. Debbie, you want to add more to that?
No, I thought that was perfect. That was great. And so one of the things people might be surprised by is how much on our teams we map out where the practice opportunities lie. And we really do think about how many are they getting, how far apart are they? And one of the things that lets us do is practice with harder problems, because as kids learn more, the practice that comes 2 units later can use bigger numbers or maybe can interweave a new idea, so it's more complicated. And so in addition to being linked by research to longer term learning, it actually makes the practice richer, more complex, that kind of thing. But we have large wall charts and spreadsheets and stuff that sort of map out those opportunities so that it's not left to chance, even if when a teacher's first experience of the program, it might feel like it is. So if it gives anybody any peace of mind, know that there were a lot of counts and charting, and but it is one of the things that we worry about when people maybe run out of time for that, or maybe think, well, this isn't that important because it's not the main focus, because we do then rely on kids having all those opportunities to practice. So it's important, and maybe that'll come up later, to think about how to fit all the pieces in, including those practice pieces. Toni, you mentioned something about the games. I think that kids, if they play something like Beat the Calculator or Top It with a whole deck of cards, they're actually going to get more addition problems, more varied addition problems than they would even with a very long worksheet. And they're probably not going to be as spent or having such negative feelings for some of them about what math is like, but they will still have had every problem that comes up when 2 cards are put down and we have to add them or do that. So people
they'll actually have fun. We see students when they get to pull out the math games and play the math games. It's math in a playful way. They're having fun doing the practice in a way we don't often see when we say, pull out your flashcards or complete 25 problems on a sheet of paper.